matrix. Tell me something about it. I don't have it right in front of me.
Zinc plus sulfur equals
Plus,
zinc plus sulfur produces zinc sulfide, and the charge on sulfur is 2. The charge? The substrate
is,
2. And then the coefficients is given on zinc sulfide is 2. And then,
awesome. Give me the information that you're given in the question.
25 grams of zinc.
25 or 25.0?
25.0.
Funny how I know that. Okay.
Probably misses.
Well, you guys just automatically disregard zeros. But then it affects your answers because you've now changed the number of significant digits. 30.0 grams of sulfur. Okay, so zinc is 65.341. I was going to say 31. And sulfur is 32.07, so that would be 64.14. Do you prefer dimensional analysis? All right, so here you've got initial amounts for both. Have you figured out which one is your limiting reagent?
Yeah.
Which one was it?
Zinc.
Zinc. So all of zinc got used up. Some of the sulfur did, but not all of it. So in order to figure this out, you've got to figure out how much sulfur got used up by that amount of zinc. So we're going to try and figure out the grams. Oops, why did I put 8? These are called allotropes. An allotrope is the same element but a different number of that element. So there's S2, there's S4, there's S, there's S8. So we want to figure out the grams of sulfur used up by our limiting reagent zinc. So if we want to find grams of grams of sulfur, do we have any ratio that has that in it? Grams. Mole ratio? Not the mole ratio. It does. Mole ratio is just for moles. I want grams of sulfur. Any ratio up there that has grams of sulfur in it?
64.41 grams.
Yes. So you're going to start, if you're going to do dimensional analysis, 64.14 grams of sulfur for every 1 mole of sulfur. Now I use mole ratios. I convert between the moles of sulfur and the moles of our limiting reagent. So 1 mole of S2 requires 2 moles of zinc. But now I need to get rid of moles of zinc. So I'm going to multiply this by a ratio that's got moles of zinc and grams of zinc. Now I'm going to multiply that by my grams of zinc that got all used up.
So you use the grams of the limiting group.
Yes, because that's going to tell me how much sulfur was used up by all that 25 grams. So then 64.14 times 25 divided by 2 divided by 65.41. So my guess is it's going to probably be about 12. What?
Human calculator.
Well, you know how I did that?
Or she did this.
That number is pretty much that number, so they cancel, so 25 divided by 2. See? Mental math, because I was forced to know my times table as a kid. The more math you do, the more independent you become in terms of using it. Okay, so 12 point,
2573.
all right, 12.257 grams of S2 used up. We had 30 grams. So to figure out how much is left, we take our 30, subtract the amount used. That will tell us how much is left over. Right, 29, 30, yeah. So about 17.8 grams. So 30 grams of sulfur is really kind of over the top for this question, because you only need 10% extra, right? To ensure a reaction goes to completion, you only really need 10% extra. So we could have got away with this with 12 plus 10%, about 15 grams.
So what we found was that, like by doing this, was that they used 17.8 grams extra of sulfur than they actually needed to.
Yeah. Yeah, so basically, we figured out how much the reaction actually used. That told us how much we had left over. So you could technically then tweak your reaction. I can use a lot less, which means I can save money.
So they didn't do their math.
No, not that good at doing their math. Could not have been a 3U class. Okay?
0.3822.
I mean, it's literally the simplest thing ever.
Okay. What are now the moles of sulfur? Waleed?
0.4677.
77? Thank you. So that's how many moles we have. You already have that information because you've done limiting reagent, you've done theoretical yield. So now what you're going to do, can you see that? Okay. Now what you're going to do, you've already identified this as your limiting reagent. So you're going to convert, you've already done part of your calculation, right? You've got moles. Convert the moles of zinc to moles of sulfur. So convert, cool. Convert moles of your limiting reagent to moles of sulfur to determine how much gets used up.
I did formulas because I didn't know what that meant. She just showed us. That's what I'm doing now.
Okay, convert moles to moles of your excess reagent to figure out how much of our excess reagent is used up. So, 0.3822 moles of zinc. The ratio is 1 to 2. We have zinc, so it goes on the bottom. We want sulfur, so it goes on the top. So we This will tell us how much sulfur just got used up by our 0.3822 moles of zinc. Are you okay with that? You can do one of two things. Convert that to mass, subtract it from 30 grams, or subtract that moles from moles here, and then multiply that by the molar mass. So which one do you want to do? Do you want to work the first one? So, mass is equal to moles times the molar mass, so 0.1911 moles times 64.14 grams per mole equals
2571.
I feel like I've seen that number before.
Hold it, what? This is the molar mass of
Sulfur,
And then you gotta.
because we have moles of sulfur.
oh, we found
Okay, so now we figured out how many grams of sulfur were used up by 25 grams of zinc. Subtract that from 30, and you get the same answer,
17.8.
17.8 grams.
Yield just means how much you get.
So 12.257.
12.2, wait, how about this question? 12.2 is how much of sulfur you need to get that ZNS product. The product.
What's the yield?
The yield that you got was 30.0 grams. Pretty sure. Or
So the yield is what you started with?
Which substance is the limiting reagent? So don't think you need to do two sets of calculations. We know we've got 3 grams of this. This is our excess reagent. So we only have to do our calculation once to figure out our theoretical yield. We don't have to compare anything. So we need the molar mass of silver nitrate. What have we not done that we have to do? Balance it. So balance this reaction.
2-0 or 2-1-2-1.
Which substance, without looking at your solubility table, is our solid product?
Sodium.
sodium.
It's the chromium, because all nitrates are soluble. All nitrates are AQ. So that means silver chromate is our solid. Okay? Okay? So, theoretical yield. However you do it now. Figure out the mass of silver chromate we can theoretically make if 3 grams of silver nitrate are used. So whether you're doing it dimensional analysis or by formulas, figure out your yield of silver chromate. No. I can't do that kind of math in my head. So try doing it your way rather than looking at what I'm doing.
Do it that way. And what you're doing. Tell me you have the answer right. Okay, you,
So 16 on the dot.
what's that?
Yeah, those are
Dimensional
now
analysis.
your limiting ingredient is gonna be the 37. Because that's the limit that you can make. Because you can only make that
Okay,
much
so
of the elements that you have.
find the number of moles of silver nitrate. So your mass divided by your molar mass. Then convert that to the moles of your product. Using your mole ratio, what you want to what you have. That will give you moles of product. Multiply that by the molar mass of the product to figure out your yield. How many people just use dimensional analysis to figure this out? Did you get the same answer? Yay. Well done. Do you like dimensional analysis? Formulas. Yep.
I'm kind of having a hard time as to like how we started it. Like the question didn't really explain what we were supposed to do.
Well, if you read a little bit further, it says, what is the percent yield, right? And it says that we yield 2.81 grams of precipitate. So we're getting 2.18 grams of our solid. So to figure out percent yield, we need the theoretical yield
Of the other one?
of the solid. So we know that we have to calculate the mass of silver chromate that we can make from our limiting reagent.
But don't you need to know, the theoretical yield of?
That's what we're just figuring out.
Nitrate?
No,
Because then you can find the percent of.
no. We're given mass of silver chromate that's formed in the lab. To do percent yield, we take the actual divided by the theoretical.
So theoretical is the one that we solved.
That's correct. You solve for the theoretical yield. Because theoretically, if everything in the lab goes perfectly, we should make 2.93 grams.
And would we be always given the actual yield?
Yes. Or you're doing a lab and you figure that out in the lab. Okay?
So then you, for percent you do theoretical divided by actual or actual divided by actual?
So our actual amount was 2.81 grams. Our actual yield was given to us in the question. So 2.81 grams divided by our theoretical times 100% equals 95.9%. So it's 96% good.
That's pretty good.
That's pretty good. That means we get 96% of what we should get. So reasons why you might not, some of the product got stuck to the stirring rod or your beaker, you couldn't rinse it out. Some of the solid was so small it went through the filter paper, you couldn't filter it out.
Theoretical is 2.9.
Did you do dimensional analysis? 'Cause I don't know.
What number did you get?
Question.
I got
At the very end, so third last word.
1.98.
What did you start with?
The molar mass of Na2 chromate. So
No.
2 chromate. chromate.
silver chromate.
So I gotta do 331.
So you should start with the 331.74. Because we want,
Aren't we trying to find the excess?
we're trying to figure out the theoretical yield. Which Emily pointed out is two totally different things. Are we okay with this? Sort of? Sort of okay? Sort of? Okay, turn it over.
I have a question.
Yep.
So when we find the actual, or when we find the theoretical yield, we always have to use the limiting? We can't use the accessory?
Correct. Because we've run out now of one of our reactants, we can't make any more product.
Oh, so you always have to use it the small one?
So you always use the smaller one because that means you've used up all of that reactant that's done left, can't make any more.
Oh, okay.
All at the whole class.
I'm just telling you, I'm not doing CPR.
No, like.
That's right, because your heart would have burst. Okay. What kind of a reaction is this?
Single displacement.
Single displacement. So now we're going to form zinc chloride. What's the charge on zinc?
3.
2. And we will be bumping out chromium.
That's supposed to be an S or,
That's a C.
no, I mean.
Oh, yes, that is an S. Okay, balance it.
Yes. No, 2, 3, 3.
Stop it!
So what are our coefficients?
How much is that?
So you have about limiting 3.
Correct?
Only has, like, gets all used up.
All right.
That's when you figure out.
So it says, write a balanced chemical equation. Done. What is the theoretical yield? This is not anything different from what you've been doing for the past couple of days. What is the theoretical yield? That is the maximum amount of product we can make from our limiting reagent. So whether you use formulas or dimensional analysis, this is where you're going to figure it out. So you can do this part. Oh. Yep. Okay, everybody has something to work on. You're either working on the formulas or you're working on dimensional analysis.
I'm so happy.
CrCl3 is
For dimensional analysis, you figure out your two masses. If you are doing formulas, you should get one of the same masses. So Ronak, which one of these two numbers is smaller?
Tough question. The first one.
Tough question.
So this is our theoretical yield, and our limiting reagent is the reactant it came from.
CRC. So this is the
How much are limiting?
5.10
Are you guys okay? Are you doing formulas? Have you figured it out?
Okay.
These moles of your reactants.
I'm so happy right now.
Okay? So that's how many moles of reactants. Now, you've got to use your mole ratio to convert to moles of the same product. So you're going to pick chromium. So you've got to multiply the first one by 2 chromiums over 2 chromium chlorides, what you want over what you have, and then the second ones you're going to multiply by 2 chromiums over 3 zincs, what you want over what you have. The one that produces the smallest amount of moles of chromium will be your limiting reagent. So the mole ratio comes from your coefficients.
Yeah.
Huh?
He hasn't done it yet.
So you should get these 2 moles of chromium. Which one is smaller, Ali?
I have a better question. What was that number out for?
The one on the left is smaller. So that is the moles that you use to calculate your theoretical mass. So you take
Is
mass.
that an 8?
Shh.
A 6?
Look right above it.
Ah.
So take 0.11746 moles times 52 grams, and that will give you 6.11 grams of chromium. So, Wally, did you get the same number, 6.11? Okay. How do you do percent yield then? What numbers do we need? Wally? So now we take 5.10 divided by 6.11 grams, our theoretical yield, times 100. Shh. And we get our percent yield, which is 83.5. Not as good as the last reaction that we did. Okay? When you do a single displacement reaction, when you have your solid reactant in there, it's hard to get a lot of the product off. Okay?